All right, guys. Welcome to the first PowerPoint for WT74. Okay, so this is covering GMAW and FCAW equipment and filler metals. Okay, upon completion of this module, you'll be able to explain gas metal arc welding and flux core arc welding safety, explain the characteristics of welding current and power sources, identify and explain the use of FCAW equipment in the following transfer methods: spray transfer, globular, short circuit, and pulse. Identify and explain the use of GMAW and FCAW shielding gases and filler metals, and set up GMAW and FCAW equipment and identify tools for weld cleaning. And you'll be able to set the equipment up. All right, gas metal arc welding uses an arc to melt a consumable wire electrode and fuse it to the base metal. When the flux core cord wire does not require an external shielding gas, the process is called self-shielding, or FCAW-S. Okay. Constant current and constant voltage. Transformer rectifier power sources. The transformer rectifier power source uses a transformer to convert the primary welding current and a rectifier to change the current from AC to DC. Here is an example of an older transformer rectifier system with an external wire feeder. Okay, inverter power sources. So in our shop, the XMT 350s are inverter type power sources. Inverter power sources increase the frequency of the incoming primary power. This provides a smaller, lighter power source with a faster response time and more control for pulse welding. Okay, typical weld program sequence. This has to do with when you're doing pulsed transfer. Okay, the transfer methods here. Spray transfer. Spray transfer creates a lot more heat when welding and is suitable for thicker materials. Globular. You can see the difference in the transfer methods there. Short-circuiting transfer. Short-circuiting transfer is probably one of the most common transfer methods used in MIG welding. It does good on materials, up to 10 gauge or even 3/16, but most of the heat is created within the electrode, so it has limited penetration and should have limited use in thicker sections. Okay, joint designs for FCAW with CO2 shielding gas. So we actually use the one on the bottom when we do our test plates within the course. Here's an example of a couple different wire feeders. A few more double wire feeders where you could have a machine set up for two different wires, two different processes at the same time. There's also some portables there on the bottom. And then the Cobra-matic there on the bottom right, that's used for welding aluminum. The gun itself actually has a small drive roller that helps to pull the aluminum wire through the machine, through the gun. Okay, this is just a typical setup. Ours looks slightly different, being that we have Millers, not Lincolns, but it's basically the same. You have drive rollers that are tensioned that push the wire through the gun. Okay, this is a knurled roller. This is what you'd use for a flux core application, where you're going to use slightly less pressure, but the knurls help for it to grab the wire to push it through. V-groove rollers are used for solid wire. We actually don't use any U-groove rollers in our shop, but they are available. Okay. Okay, the basics of the gun. you know, they're all slightly different, but you have a gas nozzle, a contact tip, and a gas diffuser on the end. Those are all consumable type wear parts. Oh, wrong way. This is a spool gun. These are pretty commonly used for aluminum for smaller jobs. Put a 3-pound spool on the, or 1-pound spool, I mean, on the gun, and it feeds it through the gun for doing aluminum. It's a little cheaper to set up than like a Cobramatic or push-pull system. It's pretty common for guys that don't do a large amount of aluminum welding. Cooling units, we don't use any of these. Okay, shielding gas. Shielding gases are used to displace atmosphere from the weld zone and to prevent contamination of the weld puddle by oxygen, nitrogen, and moisture. Flow meters are the most accurate there on the left. That's what we run on everything in the shop. You will occasionally see regulators also. Regulators are actually a lot of times included with the machines when you buy them, at least the smaller ones. Here's a list of different shielding gases and what they're used for. In our shop, we use an argon CO2 mix. Let's see where they have it listed. It's a 75-25 argon CO2 mix. So short circuit transfers on mild steel, it's listed there. And we also do a 90-10 for spray transfer as well. Okay, AWS classification for filler metal. Okay, it's really similar to what we did with the electrodes. You know, ER or E, you know, designates an electrode or rod for ER, or use only as an electrode with an E. 70 on these, or the two numbers listed are tensile strength and 1,000 psi increments. And then beyond that, we can have an S or a C for a solid or a composite wire. And then we have different suffixes here depending on what their, you know, what shielding gas you use, what requirements the electrode meets, and if it's a special filler metal for nuclear use. So quite a bit here about wire. You know, I'm more concerned that we know about the low alloy wires. So like on this page here, that what these different codes are going to tell us. So we've got the ER or E. You know, the first two digits after the E or ER are going to be your tensile strength. Then you're going to have either an S or a C. It's either a solid or a composite wire. Then you have alphanumerical number, you know, alphanumerical indicator for the chemical composition of the solid or the chemical composition of the weld produced by the composite metal, and then designations for what codes are met. Okay, we're not going to worry too much about stainless currently, or aluminum, or copper, nickel. Okay. Okay, this diagram is of a basic system. You guys have all been welding with it, so I think you're pretty well versed on what we've got here. All right, guys, that concludes this PowerPoint.